right, so I want to run some simulations about how to show that different factors can in fact affect the stream's energy. Here's the first one, okay? I have two surfaces here. One seems to be smooth, one seems to be bumpy. If I place them on top of this brick to make a slope, okay? And I place this block with a target on it right at the edge of this ramp. And I drop this tennis ball, okay? I can measure how far that block got moved. It got moved 18 centimeters. If I replace that with the bumpy surface, okay, here's the bumpy one, okay, with lots of stuff in the way, put my block back, roll my tennis ball down again, I can measure the distance that that block moved, which is 1 centimeter, showing that there's a difference between how much energy is given to the object moving downhill, which changes how much it can move another object. The second one is a little bit different. Here I have a ramp. At the end of the ramp is 25 marbles, okay? And what I'm going to do is I'm going to take some water, and I colored it blue so you could see it. I'm going to measure out, let's see, I'm going to measure 20 milliliters of water. And I'm going to take these 20 milliliters of water and I'm going to pour it from at the top of this ramp. 20 milliliters did not seem to move any of those marbles. But if I change it from 20 milliliters, and instead of using 20 mils of water, if I use 100, and I let it come down from the top, it moves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I'm sorry, these are 45 marbles. It moved 30 out of the 45 marbles off the surface, showing you that adding more water gives more energy to move more stuff, our fake sediments, marbles. We have another simulation to look at. This one, okay, is a setup where I have a ramp again, showing you slope. But what I'm going to do is I'm going to prop the ramp up on top of these different blocks. The first block I measure is 3 centimeters tall. The second block I measure is 11 centimeters tall. And what I'm going to do is I'm going to take the 3 centimeters tall block. I'm going to take a ball, which is going to represent water. I'm going to take this little piece of aluminum foil and rest that here. And what I'm going to do is I'm going to let the ball roll down the ramp and use this stopwatch to figure out how much time it takes for the rolling ball to push and transport this foil off of the ramp. Here we go. Okay, go. Get in there. All right, it was about 3 seconds. Now, what I'm going to do is I'm going to switch it to the higher ramp, okay? Put my foil here. Don't go anywhere, foil. I'm going to drop my ball and see if there's a difference in time. Less than 1 second. Get back here, marble. Okay, in less than 1 second, I was able to push the same exact piece down the ramp, showing how changing the elevation can affect how much energy the flowing marble has. The last one here is going to be I have a marble inside this pan, and what I'm going to do is I'm going to spray it. I have 2 different bottles. I have one bottle where the spray is squished together, and another one where the spray is set to being missed out. I'm going to first use the jet sprayer, and I'm going to count how many pumps it takes to get this marble across the pan to the finish line. 1, 2, 3, 4, 5. 5 squirts, and it's gone. Let me try the spread out bottle now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The marble's not even going anywhere. So it looks like having the water squeezed together has more energy than having the water spread further out. These different demonstrations model the 4 different factors that affect a stream's energy. Okay, we have concentration, we have velocity that you saw coming down the different heights of ramps, we have volume of flow, where the more water we dumped was able to move more marbles, and we finally have here we have turbulence, right? Or the more crowded stream bed caused the energy to decrease. What you're going to do is you're going to be creating your own ideas for simulating one of these concepts. Can't use mine, okay? You got to think of something on your own where you have 2 different options. Like, for example, I have bumpy and I have smooth, and you're going to do something measurable to compare if one setup shows more energy than the other setup. All of my samples did that. I had bumpy and smooth, I had high volume of flow and low volume of flow. I had a steeper slope versus a gentler slope, and I had a high concentration and a low concentration. Okay, and I was able to do some sort of quantitative measurement in all 4 of my models. I measured time, I measured the amount of sprays, I measured the amount of volume of flow, and I measured the distance that the brick was pushed when I dropped the tennis ball down the bumpy or smooth path. So you want to try to think of a way to have measurable differences to prove a point, okay? And that's how this is going to work.